In this lesson, we'll explore how statistics can help us in project management. Let me start with a question your boss typically asks. Your current plan shows the project finishing on October 15th. What are the chances it will be done a week earlier? How many more days do you need to be sure that this project is completed? And here's the truth. The only way to answer these questions with confidence is to use statistics and probabilities. Your response will be clear and, most importantly, justifiable. When we build the activity on arrow diagram, we assign specific durations to each task. But task durations are not predictable. Every task carries uncertainty. We might have an optimistic scenario where everything goes smoothly and the task finishes earlier than expected. Or a pessimistic scenario where Murphy's Law applies. To capture this reality, we use three key estimates for each task: the optimistic duration, the most likely duration, and the pessimistic duration. Then we assume that the task durations follow the statistics of the beta distribution. This let us compute two very useful values: the time expected, TE, and the standard deviation, sigma, of each task. Both formulas are shown here. It's a good practice to label tasks in the activity on arrow diagram with the respective durations and standard deviation. This makes the diagram clearer and easier to analyze. Each project completion depends mainly on the critical path. We calculate two things for that path: the mean duration as the sum of the expected durations of tasks along the path, and the standard deviation as the square root of the sum of the variances of those tasks. Important to remember, we never add standard deviations directly. We always add the variances first and then we take the square root. By moving from best guesses to probabilistic estimates, our project duration becomes a random variable following the normal distribution with a known mean and standard deviation. It's well known that the z-score is associated with a corresponding probability, and vice versa. If you know the probability, you can find the z-score. You can do this using lookup tables or more easily the built-in normal distribution functions in Excel. The key idea: any probability interval can be expressed as the product of z times the standard deviation around the mean. This is the bridge between raw data, probability, and confidence intervals. Now let's apply this to the duration of the critical path. The project delay or acceleration is equal to the z-score times the standard deviation of the path. If the result D is positive, the project is delayed. If D is negative, the project is ahead of schedule and is accelerated. This relationship translates statistical quantity directly into project performance outcomes. Let's return to the questions from your boss. First question: what's the probability project finishes 7 days early? Since you already have calculated the standard deviation of the critical path, you can combine it with the 7-day acceleration to compute the probability. Your answer will be: we can finish 7 days earlier with 36% probability. Second question: how many more days do you need to be sure that this project is completed? First, we will interpret what "be sure" means. We translate this to an 80% confidence level. Then, the additional time needed will be equal z-score times standard deviation. So your answer will be We will need 17 more days to be sure that the project is completed with an 80% probability. Of course, 80% is only an assumption. Your boss might expect 90% or even 95%. But regardless of the chosen confidence level, the calculation process is exactly the same. That's the real power of statistics in project management. It turns ambiguous qualitative assertions into clear and justifiable answers. In the rest of this lesson, we'll explore more complex cases like projects with multiple critical paths and deeper statistical models for analyzing schedules. These tools would sharpen your ability to predict and manage project outcomes.